So we want to calculate the following definite integral. And now because it is a definite integral, of course we could use technology to calculate this. But that may not give us the exact answer, and we might need that kind of accuracy depending on our application. So let's talk about doing this one by hand. Now, what we see under the radical is an x squared plus 3, and then there's an x outside of the radical. So this is a very good candidate for u substitution. In fact, we're going to let u be that inside function, which is the x squared plus 3, because then the du is 2x dx. Now, we need to get in our du, which means we need 2x dx inside our integral. I have x dx. Well, I can force a 2 in there, and I'll multiply by a 1/2 on the outside to compensate, and there's my 2x dx. So our substitution is going to be complete. So 1/2 times the integral, I'm going to leave the limits alone for a second, and we'll come back to them. 2x dx is my du. This is just going to be square root of u. Again, 2x dx is exactly our du. And there's our integral written almost completely in terms of u, except for the limits. All right, but what we'll do, these limits here are x values. What we'd like them to be is u values, and here is the relationship between x and u. So we can actually just go ahead and calculate those limits. So the upper limit is 5 for x, so 5 squared plus 3, which is going to be 28. And the lower limit is 1 for x, so 1 squared plus 3 is 4. And so now my integral will go from 4 to 28. Now these are u values. What that means is I can forget about this whole line now and just solve it from here on out. I don't have to substitute back or anything like that. I think it's a really big advantage. It helps keep things very clear. Now, square root of u, probably first thing we'll do is rewrite it as u to the 1/2. And so we have 1/2. First thing you do is increase the exponent by 1, so 3/2, and then divide by the new exponent. And we have not put in our limits yet, so 4 to 28. Let's do a little bit of simplifying, and then we'll worry about the limits. So dividing by 3/2 is the same thing as multiplying by 2/3, so I have 1/2 times 2/3 times u to the 3/2, again from 4 to 28. Those 2's will cancel. So I'm going to have a 1/3 out front, and now let's go ahead and put in our limits and take the difference. I'm going to have 28 to the 3/2 minus 4 to the 3/2. Now we'll simplify as much as we can, but there may not be that much we can do. For instance, 28 is not a perfect square, so we really can't make that look a whole lot nicer. I'm going to leave it as 28 to the 3/2. 4, on the other hand, is a perfect square, so we can take the square root of 4, which is raising it to the 1/2 power, and then which is 2, and then cubing that, so that's 8. Now that's a nice exact answer, and I would just go ahead and leave it that way. Now, of course, we could check this with a calculator or with Wolfram Alpha or some computer system, but we have a nice exact answer there. So if we need to use it in another application, we know that we have no round-off error.